Hey there. Let me ask you something wild. What if you could rewind time? Not just back to yesterday or last year or even 1,000 years ago. I'm talking about rewinding all the way back, to the absolute beginning of everything. According to science, everything started from something incredibly tiny, unbelievably hot, and impossibly dense. And then, in one incredible moment, it began to expand. Welcome to the story of the Big Bang. About 13.8 billion years ago, our entire universe existed as something smaller than an atom. All the matter, all the energy, all the space in the cosmos, squeezed into one incredibly tiny point. This wasn't just a tiny ball floating around in empty space. There was no empty space around it. There was no around it at all. This tiny point was the entire universe. And it was unbelievably hot, around 10 to the 32nd power Kelvin. That's a 1 with 32 zeros. So hot that even the tiniest particles couldn't exist yet. And then, in one incredible moment, it began to expand. The universe didn't explode into space. Space itself began to expand. Stretching. Growing. Carrying everything with it. Alright, let's dive into those first moments. In the absolute earliest instant, what scientists call the Planck epoch, our physics completely breaks down. We simply don't have the equations to describe what was happening. The universe was so hot, so dense, so extreme, that our current understanding of reality just doesn't apply. But as the universe expanded, even in those first tiny fractions of a second, it started cooling down. When things expand, they cool off. It's the same reason spray from an aerosol can feel cold. And as the universe cooled, amazing things started to happen. About 10 to the negative 37 seconds after the Big Bang began, that's a decimal point followed by 36 zeros, and then something absolutely bonkers happened. Scientists call it cosmic inflation. The universe suddenly expanded faster than the speed of light. In less than a blink, the universe went from smaller than an atom to about the size of a grapefruit. Inflation solved some big mysteries. It made the universe incredibly smooth and flat, like ironing out wrinkles in a bedsheet. But it wasn't perfectly smooth. There were tiny, tiny fluctuations. And those tiny ripples? They became the seeds of everything: galaxies, stars, planets, and even us. Then, as quickly as it began, inflation ended. And the universe kept expanding. After inflation, the universe was boiling, not with chicken soup, but with a cosmic soup of particles and energy smashing into each other at insane speeds. Quarks, gluons, electrons, and photons, the most basic building blocks of everything, were swirling in chaos. Every particle had an opposite twin called an antiparticle. When they met, boom, they annihilated each other into pure energy. But here's the twist that saved the universe. For every 30 million pairs that destroyed each other, one extra particle of regular matter survived. That tiny imbalance, 1 in 30 million, is why anything exists at all. Without it, there'd be no stars, no planets, no us, just endless energy. We call this mystery baryogenesis, and scientists are still trying to figure out why matter won. About a millionth of a second after the Big Bang, things finally started to calm down. The universe cooled just enough for quarks to stick together and form protons and neutrons, the building blocks of atoms. A few minutes later, around 1 billion degrees hot, those protons and neutrons began to fuse into the first atomic nuclei, mostly hydrogen, some helium, and just a tiny bit of lithium. That's it, only 3 elements from the Big Bang. All the others, carbon, oxygen, gold, iron, came much later inside stars. Those first simple atoms became the ingredients for everything that followed: stars, galaxies, planets, and even life itself. For hundreds of thousands of years, the universe was like a glowing fog. Light couldn't travel freely. Photons kept crashing into free electrons, bouncing everywhere. The whole cosmos was bright but opaque. Then, about 380,000 years after the Big Bang, the universe cooled to around 3,000 degrees. Electrons finally joined with protons to form neutral hydrogen atoms, a moment called recombination. And when that happened, something beautiful occurred. Light could suddenly travel freely through space. Photons could travel across space without hitting anything. That ancient light is still around us today, a faint microwave glow from every direction. We call it the cosmic microwave background, or CMB, the universe's oldest light, a baby photo from when it was just 380,000 years old. When scientists discovered this cosmic background radiation in 1964, it was one of the most powerful pieces of evidence that the Big Bang actually happened. After that first flash of light, the universe went dark. No stars. No galaxies. Just endless clouds of hydrogen and helium drifting through space. This era is called the Cosmic Dark Ages. But gravity was busy behind the scenes. Those tiny ripples from the early universe created slightly denser spots, and gravity pulled matter into them. Slowly these clumps grew larger and heavier. Wherever there's more matter, gravity pulls harder. So the slightly denser regions started pulling in more and more gas. Slowly, steadily these clumps grew bigger and denser. And here's where something mysterious helped out: dark matter. We can't see it, we can't touch it, but it has mass and gravity. Dark matter created invisible gravitational wells that helped pull regular matter together even faster. For hundreds of millions of years, this process continued. Gas clouds growing denser and denser, pulled together by gravity. The pressure and temperature in the centers of these clouds kept rising. Something amazing was about to happen. Finally, about 100 to 200 million years after the Big Bang, the centers of these gas clouds got hot enough and dense enough that something incredible happened. Nuclear fusion ignited. The first stars were born. Made only of hydrogen and helium, they began fusing those elements into heavier ones, like carbon, oxygen, and iron. But there's a limit: stars can't fuse anything heavier than iron. So when these massive stars ran out of fuel, they exploded in spectacular supernovas. Those explosions created even heavier elements: gold, silver, uranium, and scattered them across space. That stardust became the building blocks for new stars, planets, and eventually, us. As stars were forming and dying, they began to gather into huge groups held together by gravity. That's how galaxies formed, billions of stars orbiting around a common center. Some became elegant spirals, others round ellipticals, and some just messy blobs. But galaxies didn't form alone. They grouped into clusters, and those clusters connected into superclusters, weaving a vast cosmic web across the universe. About 4.5 billion years ago, in a quiet corner of one spiral galaxy, a cloud of gas and dust began to collapse. At its center, the sun was born. Around it, leftover material formed a spinning disk that clumped into planets, asteroids, and comets, our solar system. One of those planets, Earth, started as a fiery ball of rock. Over time it cooled, rain fell, and oceans formed. Then, around 3.5 billion years ago, life appeared. Tiny single-celled organisms began a journey that led to plants, animals, and eventually, us, humans made of stardust, standing on a planet born from the debris of ancient stars. So, how did we figure all this out? In 1929, astronomer Edwin Hubble made a stunning discovery. When he studied distant galaxies, he saw that they were all moving away, and the farther they were, the faster they moved. That meant the universe itself was expanding. And if it's expanding now, then long ago, everything must have been closer together, until it all started from one point, the Big Bang. So, how do we know the Big Bang really happened? Scientists point to 4 key clues. First, the amounts of hydrogen, helium, and lithium in space match exactly what the Big Bang predicted. Second, the cosmic microwave background, that faint glow discovered in 1964, is the leftover heat from the early universe. Third, the pattern of galaxies across the sky fits perfectly with Big Bang computer models. And fourth, Hubble's law, galaxies moving away from us, shows the universe is still expanding from that original burst. Put together, these 4 pillars make one thing clear: the Big Bang isn't just an idea, it's the story written in the universe itself. Let's talk about what the universe is really made of, and get ready because it's mind-blowing. Everything we can see, stars, planets, you, me, is called ordinary matter, and it makes up less than 5% of the universe. About 27% is dark matter, invisible stuff that doesn't give off light, but its gravity keeps galaxies from flying apart. It's like an unseen web holding the cosmos together. And the biggest slice, about 68%, is dark energy, a mysterious force that's actually pushing the universe to expand faster and faster. So here's the crazy truth: we only understand a tiny fraction of our universe. The rest, dark matter and dark energy, is still one giant cosmic mystery. In the 1990s, scientists made one of the most shocking discoveries in astronomy. They were studying exploding stars called Type Ia supernovas, perfect cosmic yardsticks, that let us measure distances across the universe. The goal was simple: see how much the universe's expansion had slowed down over time. But the results? Total shock. The expansion wasn't slowing, it was speeding up. Something was actually pushing galaxies apart faster and faster. That mysterious something is what we call dark energy, an invisible force built into space itself. The more space expands, the stronger dark energy's push becomes. It now dominates the entire universe. What is it? We don't know. It's one of the biggest unsolved mysteries in science, the invisible hand shaping the future of everything. The Big Bang explains a lot, but wow, there's still so much we don't know. Mystery 1. Why is there more matter than antimatter? The laws of physics say they should have existed in equal amounts, yet somehow matter won. Mystery 2. What is dark matter made of? We can feel its gravity holding galaxies together, but no one's ever seen or caught a dark matter particle. Mystery 3. What exactly is dark energy? Is it part of space itself or something entirely new? It's pushing the universe apart, but we don't know how or why. Mystery 4. What happened at the very first moment of the Big Bang? Our physics can't describe it. And the biggest question of all, what came before the Big Bang? Maybe another universe? Or maybe that's when time itself began. Here's one of the coolest facts about astronomy: when we look out into space, we're actually looking back in time. Light takes time to travel. So when you see a star that's 10 light years away, you're seeing it as it was 10 years ago. Look at a galaxy a billion light years away? You're seeing it a billion years in the past. That means telescopes are basically time machines. When astronomers take deep space images like the Hubble Deep Field, they see thousands of galaxies, some young, some old, each frozen at a different moment in history. So we've explored the beginning, but what about the end? Where is the universe heading? Right now, it looks like expansion will never stop. Dark energy keeps pushing galaxies farther and farther apart, faster every day. In a few trillion years, galaxies beyond our local group will drift so far away that their light will never reach us again. The universe will look empty. Stars will burn out. New stars won't form. Everything will fade into darkness. Eventually, only cold remnants, black holes and dead stars, will remain, slowly evaporating into nothing. It's called the heat death of the universe, the quiet end of everything. But don't worry, that's trillions of years away. And who knows? Science might surprise us yet, it always does. Let's bring it all together. 13.8 billion years ago, everything began as one unimaginably hot, dense point. Then, in a heartbeat, space itself expanded, faster than light, setting the stage for everything to come. The universe cooled, forming particles, then atoms, then the first light that still glows around us today, the cosmic microwave background. Gravity took over, pulling gas into clouds that ignited as the first stars, forging the heavy elements of life. Stars gathered into galaxies, galaxies into clusters, weaving the grand cosmic web. 4.5 billion years ago, one small star formed, our sun, and around it tiny worlds took shape. On one of them life began. And billions of years later, here we are, the universe becoming aware of itself. For thousands of years, people tried to explain where everything came from. Ancient stories spoke of gods, magic and creation myths, beautiful ideas but based on belief. Then came science. The Big Bang isn't a myth, it's physics. It's a story built from evidence, not imagination. Here's the most amazing part. This story isn't just about the universe. It's about you. Every atom in your body has cosmic roots. The hydrogen inside you was born in the Big Bang. The carbon, oxygen, and iron were forged in ancient stars that lived, exploded, and scattered their ashes across space, so that one day you could exist. You live on a small blue planet orbiting an ordinary star in one of billions of galaxies. So the next time you gaze at the night sky, remember, you're not just looking at the universe, you're looking into your own origin story. Every time you gaze at the stars, you're seeing your cosmic family. This isn't myth. This is reality. This is physics. This is the universe's origin story, and yours. So if this journey blew your mind, hit that like button, subscribe for more simple science, and share the wonder.